Welcome to Understand the Math. In this problem, we're given a vector y and a vector u1 and a vector u2. We're asked to do three different things. The first thing we're going to do is we're going to compute the orthogonal projection of y onto the subspace w, which is the span of our two vectors u1 and u2. We're then going to compute the distance from y to subspace w. And then lastly, we're going to write our vector y as the sum of a vector in subspace w and a vector orthogonal to subspace w. Let's begin by writing down the formula that we're going to use to find the orthogonal projection of y onto subspace w. That formula looks like this. It's y hat is equal to y dotted with u1 all divided by u1 dot u1 times u1 plus y dotted with u2 all divided by u2 dot u2 times u2. Now we just have to take a lot of dot products. Y dotted with u1 is going to give us 12 plus 6 plus 0. And then u1 dotted with u1 is going to be 16 plus 9 plus 0. And that multiplies our vector u1. And then let's do our second round of dot products. We're going to do y dotted with u2. So we have a minus 9 plus 8 plus 0. And then in the denominator, we have a minus 3 squared, so that gives us a 9. And then a 4 squared is a 16 plus 0 times u2. Now let's go ahead and add all these things up. We have an 18 over 25 times u1, and I'm going to go ahead and put u1 down here, 430. And then we have a minus 1, so let's erase this plus, and let's make this a minus 1, all divided by 25, and let's put down our u2, and that is minus 340. So it's nice that everything's divided by 25. 4 times 18 is going to be what? 36 doubled, so that's going to be a 72 over 25. And then we pick up a 3 over 25. And then 18 times 3, that is going to be 54 over 25. And we subtract 4 over 25. And then our bottom number is 0. So let's go ahead and add these up. We have 75 over 25, which is actually 3. So our answer actually looks really nice. And then 54 minus 4 is 50, divided by 25 is 2, so we have a 3, 2, and a 0. So that is our orthogonal projection of y onto the subspace w. Now let's look at part B. Part B, we want to find the distance from y to subspace w. So this distance is equal to the magnitude of y minus y hat. Let's go ahead and let's first compute y minus y hat. Our vector y up above is 3, 2 minus 5. And we're going to subtract off the vector we just computed, which was 3, 2, 0. And we end up with the vector 0, 0, minus 5. Now we can go ahead and compute the magnitude of y minus y hat. It's nice that we have some 0 components. So we're just going to have the square root of 0 plus minus 5 squared is 25. So we end up with a value of 5. So the distance from y to subspace w is just equal to 5. Now let's look at our last part. We're going to write y as the sum of a vector in the subspace of W and a vector orthogonal to the subspace of W. Our vector y is going to be our vector in the subspace, so that's going to be our projected vector y hat, plus a vector orthogonal to our subspace, which we'll call vector z. To find vector z, all we have to do is take vector y and subtract y hat. And we've actually already done that right up here. Let me highlight that so you can see it. That's our vector right there. So our orthogonal vector is 0, 0, minus 5. Our vector y then can be written as our vector in the subspace, 3, 2, 0, plus our vector orthogonal to the subspace, which is 0, 0, minus 5.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.